Hi everyone, this is going to be the last week of lectures. This week we are going to be studying about vectors and various properties of vectors which utilize things we've learned so far like Pythagoras theorem, trigonometric ratios, etc. So as a brief introduction, I asked you to fill this up with how you would answer these kind of questions, and more specifically focusing on the kind of values you have. So for example, what is your height? You could say it's 2 meters. What is the wind speed? You could say it's 20 miles per hour. What is the temperature? So you say it's 32 degrees Celsius. What is the course of this ship? Maybe you say it's northbound. Now what I mean by type of information is that we can draw a distinction between two very fundamentally different quantities here. For example, height. 2 meters is a complete information because you can sort of imagine what a height of 2 meters means. Same with temperature. 32 degrees Celsius temperature, it's pretty self-explanatory. Now when we come to wind speed, 20 miles per hour may be sufficient, but it's not complete because it still leaves the question of in what direction. Right, depending on why you are interested in this value, you may also want to know what direction. Is it 20 miles per hour east, west, northwest, northeast? None of those. So there you need two kinds of information. And the same with the course of the ship can be northbound, but you may also want to know like at, I don't know, X knots, some speed, because that's going to give you a more complete information about where this ship is headed. So these fundamental differences are categorized as two quantities, scalars and vectors. Scalars are quantities that only deal with what we call values, but more specifically it's called magnitude. So it only deals with the question, how much? Yeah. So it gives you a number, like your height, 2 meters, it's only the magnitude. Vectors, on the other hand, they have two characteristic features. They have magnitude and they have direction. So two questions, how much and in what direction. These would be things like wind speed, force applied, where it is not only important to know how much, but also in what direction. Kind of like opening a door. Now, when you open a door, your mind automatically calculates how much force to apply, but based on whether it's push or pull makes a big difference, right? And it's very normal to always, if it's a new door, you end up doing the wrong one, like you push if instead of pulling or pull instead of pushing. So that's why it's important to study vectors, because we have things where direction really changes things. It really matters. So that's the basic idea. Think about what other quantities you face in everyday life and which of those are scalars, which of those are vectors. And you can send me a list, something that does not include what I already discussed, as an email. If you send it to me, that's a bonus. Okay, now that we have been introduced to this thing called a vector, we need to learn some rules of talking about them. So naming a vector, we use capital letters with an arrow on the top. So examples would be A with an arrow, and we read this as vector A. B with an arrow, vector B. And the next thing is how to draw them, again using arrows. So for example, I can say this is vector A, or this is vector B, or this is vector C. Now in the textbook and other places, you may also notice that sometimes the arrow on the top here is skipped and it's written as a bold character, but that's not really feasible when you're writing by hand. So this is a universally accepted notation, and we use this arrow where the arrowhead points to where the vector is pointing. So that's the direction. Okay, so now we know how to talk about vectors using the appropriate language. There is one important property of any vector. It's called translation invariance. It sounds complicated, but it's basically this here. For example, if there's a weather prediction of 20 miles per hour wind blowing northeast over the entire island of Oahu, what that means is, if you look at this, our island, not drawn accurately, northeast, so there's a wind blowing in this direction across the island. What that means is, no matter where you are, let's say you are here near Kaina Point or you are here in town, the direction is still northeast, right? They're still the same. If you are here and your friend is here and you're communicating about which way the wind is blowing, you're going to have the same answer. You would say it's blowing northeast. Another way of looking at this is, if you notice, these arrows are parallel. So what this means is, if I take a vector pointing here and its length, let's say its magnitude is the length of this pencil, and I move it parallelly somewhere else, it's still the same vector. No information is lost. Yeah, it has the same magnitude and it's pointing in the same direction, but only as long as they are parallel. If they are not parallel, if I turn this, now it's changed. Now it's a different vector. So what this means is, vectors can be moved around, but specifically right, left, up, down, or combination, without losing information, which basically means without changing the vector, but no rotation. Okay, because the action of rotation will change the vector. So if this is a vector, I rotate it, that's a new vector. But if this is the vector and this motion is called translation, I move it up, down, keeping the direction the same, then these are all the same vectors. Okay, let's end this video here, and next video we're going to talk about how to more concretely specify a vector. So far we are just thinking of vectors as arrows with certain lengths, and they give us some value in some direction, but we're going to make that notion more concrete in the second video.